Assalamu alaikum all of you. Welcome to one more topic for O-level computer sciences. Now today we are going to do with the Boolean logics, or you may call this topic as with the name of the logic gates as well. Earlier, like before 2023, that was logic gates and it was actually the part of paper 2, sorry paper 1, and now it's known as the Boolean logics and now it's a part of paper 2. So it's a quite marks scoring topic as well, you might say. Now, when it comes to the Boolean logic or logic gates, so what is the definition of the terminology logic gate, or what are actually the logic gates? So, as we say that whenever we are going to construct any sort of a building, you might say, so what is the basic requirement for creating of that particular building or that particular plaza or something like that? So, the basic requirement for creating or for building that particular plaza or something, so that is, you may say, it's a block. The block is the basic requirement, unless you won't be having a block over there. Similarly, you can't develop any sort of the building over there. See, now coming towards the logic gate, so what is the connection with the building and the logic gate? So similarly, as of the electronic circuit, whenever you are going to construct any sort of the electronic circuit, so the basic requirement for creating those electronic circuits are known as the logic gates. Until unless there are no logic gates implemented over there, there will be no electronic circuit over there. Now, electronic circuit might be of for example, system that you guys are watching my video on. Okay, now it might be of a cell phone as well, it might be of an Apple Pencil as well, it might be of my iPad as well, or any such stuff. It might be the you may say electronic fans as well, air conditioners as well. So any such thing, you may say that it is known as a Boolean logic, or you may you may say that it do applies a logic gate in it. Now, when it comes to the logic gate, so for the logic gate, what do we say? There are overall, or you may say when it comes to the types of the logic gates, so overall there are 7 different types of the logic gates. We may call them as the AND gate, NAND gate, OR gate, NOR gate, XOR gate, NXOR, or you may call it with the name of the XNOR gate as well. And then finally, the 7th gate is known as the NOT gate. So overall, there are 7 different types of the gate. Repeating myself once again: AND, NAND, OR, NOR, XOR, NXOR, and finally NOT. Now, you may see that there are the gate name of the gates written over there, and just in front of the gates there are symbols over there. Okay, when it comes to the electronic circuit, so you do not see those gates in this particular manner. How are you going to see them? Let me draw it for you, a bit of it. So you will be able to see them in this sort of a particular thing. So it will be in some sort of this shape. This is known as a chip or an IC, integrated circuit. So this IC is actually representing the AND gate. For example, you may say that for the AND gate, it's 8056 is the number of the IP, if I'm not wrong. So this is an input pin, or any other pin you may, sorry, it's an output pin. It's a ground pin. Ground means that you do put an earth when you are going to come up with an electronic circuit, and the remaining of them are the input pins over here. So actually the gate looks like this, but for our understanding or for the electronic terminology, we do say that the gates have different symbols, and the symbols can be seen on the screen right now with the AND gate, NAND gate, OR, NOR, NXOR, and finally it's a NOT. Now, for the symbolic representation, you may see, let me zoom it in a bit more. So for the AND and the NAND gate, you may see that there in the symbolic representation there is a minor difference, and the difference is of this bubble. The difference is of this bubble. So just because of this bubble, the NAND gate, so the NAND gate may also be termed as the bubbled AND gate. May also be termed as the bubbled AND gate, just because of this bubble that you can see in front of the NAND gate. Similarly, for the OR and NOR, both are same, but there is a difference of this circle, or you may say bubble. So similarly, the NOR gate may be called as the bubbled OR gate as well. Similarly, for the XOR, it goes, sorry, for NX XOR, it goes same. Just because of this bubble, it may be called as the bubbled XOR gate as well. So now we are clear with that. Okay, now coming again with the symbolic representation. So you might see that this one is an output. So from AND gate till the NOR gate, you do have a single output, but you do have two inputs. When you will be going in your AS level, so in AS level, you will be saying that there are three inputs. Okay, and now when I drawed this one and the circuit, so I just showed 1 2 3 4 5 6 7 8 9 10 11 12. So I placed 12 inputs. It might be the 16 inputs as well, it might be the 12 inputs as well, it might be the 8 inputs as well. That means the values of the inputs might change, they might be variable, they are actually variable. Not might be, they are actually variable. So the inputs are variable, but output remains only one, it's a constant, so it's a 1 over here. So from the AND gate till the NOR gate, you may see that there are two inputs at a time but a single output. But when you come to the NOT gate, so the NOT gate is having only a single input and a single output, only a single input and a single output. So that over here, the number of the inputs and the number of the outputs are same, that is 1. Okay, now first of all, coming when it comes to the explanation, so first of all coming towards the NOT gate. First of all, now for the NOT gate, as I told you that it is having only a single input and a single output, so we do call it a revert gate. As we know that in binary we do have only two terminologies, that is one that represents on and the other one is 0 that represents off. One means on and 0 means off. So as I told you that in the NOT gate we do have only a single input and a single output. So if 1 is entered into the NOT gate, so obviously it will be reverting that particular 1 into a 0, and if 0 is entered into the NOT gate, so it will be reverting it and it will be giving an output as a 1. So 1 will be converted to 0 and 0 will be converted to 1 for the NOT gate. Now do remember that we do have two different types of the expressions. One is the Boolean expression and the other one is the logical expression. Now for the Boolean expression, what is a Boolean expression? Boolean expression is something we do utilize the symbols over there. It is actually a symbolic representation of a gate that is being applied. Whereas when it comes to the logical expression, so in logical expression we do mention the name of the gate that is being utilized between the variables. Now as we know that for the NOT gate we were only having a single input and a single output. So what I mentioned over here, A, and above that A I placed up a bar. Above that A I placed up a bar right over here. So this bar actually represents the complement. This bar actually represents the complement, or you may call it as the revert part as well, or you may call it as the NOT gate as well. Revert, NOT, or complement. So all these three things are same over here. So do remember that this bar is actually representing the NOT gate. So for the A, we were applying a NOT gate over an A, so we placed up a bar over here to represent a NOT gate. For the logical expression, we do write not A, or either we do write A not 1. Okay, now why it is A not 1? Because by default, each and every input is 1. So if we are applying a NOT gate on any of the input, that means we are converting it to a 0. So to write a 0, we do say A not 1, that means it's A is a 0 right over here. Then it comes to the truth table. Now what is the truth table? So truth table is actually something that whatever, it's a dry run of a program. Now what do you mean with the dry run? Dry run means that we are not placing up in a circuit right now. We are just checking it out. If we are placing these values as an input, so what will be the output that we will be getting? So as we know that it's a single input and a single output. So if you can see, no bar because it's the original number, and it's a bar over here because it's a NOT gate has been applied over here. So for 0, it will be a 1, and for 1, it will be a 0 right over. 0, 1 and 1, 0. So this is how a NOT gate is actually working on. Coming back to the gates. So as we say that AND, and then we do have a NAND gate. Now for the NAND, this means not AND. This means not AND gate. So NAND, in the NAND, N represents the NOT. In the NAND, N represents a NOT. So that means NAND is the reward of AND. Similarly, NOR is the reward of OR. AND XOR or XNOR is actually the reward of XOR. So now they may have the name with the bubbled end, sorry. Just because of the bubble, it may be called as the NOT end as well. So these are the two different, and it is also known as an AND gate. Similarly, bubbled OR, NOT OR, or NOR, bubbled XOR, NOT XOR, or AND XOR. So all three names can be this of a similar particular gate. Now coming towards the AND gate. Now what does the AND gate says? AND gate says that output will be high. That means, what do you mean by the terminology high? As I just told you right over here, one means on, so just add on one more thing to it. High, 1, and on. All three things are same. Similarly, low, 0, or off. All three things are same. So for the AND gate, it says output will be high if the inputs are high. Or you may say, I do have mentioned over here, if both or all of the inputs are high. So output is going to be high. That means output is going to be a 1. That if only in the condition, if both or all. Both means right now we are only utilizing 2 inputs at the moment. But if we are going to have AS level or we are going to have A2 levels, so over there we might be utilizing with the 3 inputs as well as with the 4 inputs. So both or all, until unless all the inputs are in the on state or in the high state, until then you won't be getting a 1 as an output or high as an output. So only in the condition if both or all of the inputs are high, only in this condition you will be getting a 1 as an answer or high as an answer. Again, now Boolean expression. So we do represent the AND gate with the help of the dot. For the logical expression, it's simply A and B. For the truth table, if we have input 0 and a 0, so in the output you will be getting a 0. For 0 and a 1, you will be getting output as a 0. For 1 and a 0, you will be getting output as a 0, because once again, you can see this on your screen. What does it say? Output will be high. Output will be 1. If all or both of the inputs are, it will be a 1. If all of the inputs are 1. So only for 1, 1 we do have a 1. Other than that, the rest of them are 0. Now coming towards the NAND gate. NAND gate is just the revert of the AND gate. So for the AND gate, you are only getting a 1 if both of the conditions are 1 or both of the inputs are 1. Now for the NAND gate, as it is the revert, so what is going to happen? It says output will be low. That means it will be a 0 if both or all of the inputs are high. If both or all of the inputs are high, in this particular case, in this particular condition, the output is going to be a low. So if you can see with the Boolean expression, so for the AND gate, the Boolean expression was shown in a format A dot B. But when it comes to the Boolean expression of a NAND gate, so for the NAND gate, it's just similar A dot B, but there is a symbol over here, that a bar symbol over here, that actually represents the NOT gate. That actually represents the NOT gate right over here. So we do say that output will be low. That means output will be 0 if both or all of the inputs are high. That means if both or all of the inputs are 1. So in this particular case, the output is gonna be a 0. So logical expression A and B simply. Now for the truth table, 0, 1. Okay, now neither both or neither any of them is, sorry, neither both of them is 1. So we will be getting a 1 as an answer. 0, 1, 1 is on, 1 is off. Even though we will be getting a 1 as an answer. 1 and 0, we will be getting a 1 as an answer. Now both of them are 1 right now. Both of them are 1 right now. That means both of the inputs are on right now. So we will be getting off condition or a 0 as an answer. So this will be considered as an off, or it will be considered as a low as well. Coming to the next point, now it says OR. Now what do you mean with the OR gate? OR gate says output will be high if any of them. If any of the input is high, then you will be getting 1 as an answer or a high condition as an answer. So output will be high, output will be 1 if any or all. Any is the condition or all is a bonus condition. That means either of them or all of them if they are 1. So only in this case you will be getting 1 as an answer. So if you can see right over here with the Boolean expression, it do says A, and this is the symbol that represents the OR gate, A or B, then logical expression, we are writing the name of the gate. Or for the truth table, 0 0 you will be getting a 0 as an answer, 0 1 you will be getting 1 as an answer, 1 0 again you will be getting 1 as an answer, and for 1 1 you will be getting 1 as an answer, because either of them were 1 or both of them were 1. That is the reason we are getting 1 as an answer. Coming towards the NOR gate. Now what does the NOR gate says? NOR gate says, do remember it's the reverse of the NOT gate, OR gate. So NOR gate says that output will be low, output will be a 0 if any or all of the inputs are high. If any or all of the inputs are high, so in this particular condition the output is gonna be a low. So when it comes to the Boolean expression, so we do represent the NOR gate. I'm sorry about this glitch. So or for the NOR gate, as OR gate was represented by a plus symbol, so for the NOR we will be placing a bar over here. For logical expression, we will be simply writing the NOR, the name of the gate over here. Now coming towards the truth table, so it says output will be low if any, either of them is 1, so that means the answer is going to be a 0. So for only 0 0 it will be a 1, other than that for 0 1 it will be a 0, for 1 0 it will be a 0, and similarly for 1 1 it will be a 0. So for all these conditions, because they were having a 1 as an input, either of them or both of them were having 1, so that's the reason they got a 0 as an output. But in the first condition it was both of them were low, so that's the reason we got high as an answer or 1 as an answer. Coming towards the XOR gate. Now the XOR gate says that output is going to be high, that means output is going to be 1 if the inputs are dissimilar. Now for example, there are 3 inputs, A, let's consider there are 3 inputs, A, B and C. Now out of this 0 0 2 are similar but 1 is dissimilar. Now either of them is dissimilar from the other 2, so that means you will be getting 1 as an answer. Now for the 2 things, or for the 2 inputs, what do you have? Output will be high if the inputs are dissimilar. Okay, so now how they are working? So first of all, with the Boolean expression, so we do represent a XOR gate with a plus symbol and a circle over that for the Boolean expression, and for the logical expression we write the name of the gate. Now for the truth table, it comes up with 0 0, both of the inputs are similar, so we will be getting 0 as an answer, 0 1, okay, now 1 is 0, 1 is 1, so we will be getting 1 as an answer. Now the first one is 1 and the other one is 0, so again they are both dissimilar, so we will be getting 1 as an answer. Both of them are 1, that means they are similar, so we will be getting 0 as an answer. So this is all for the explanation of the gates, that how the gates are working and what are the gates. Okay, remember one more thing. Boolean expression is not the part of the course outline now. Earlier it was, but now you do not need to write the Boolean expression. So then why did we do that? Did you waste our time? No, I did not waste your time. It will be helpful if you are going to do your AS level and A2 level. So over there you do not need to write the Boolean expressions. So you should have a concept about the Boolean expressions as well. So in the next video, we will be learning that what are the types of questions that comes with the logic gates and how do we solve them. So over that video, we will be taking the help of the logic gates. No, sorry, the passivers. Thank you so much. Allah Hafiz.